To jump to the design for additive manufacturing in machinery specifically, we prepared for you several examples which show how we do stuff, so how we design and redesign parts for machinery. But before we go to that, we have I want to show to you the additive manufacturing technologies and materials, and specifically the ones that are mostly used for machinery. Then on base of that, I will leave the stage to David later to show you the examples and how we do stuff in Additive Centre. So to start first, by defining additive manufacturing, I guess many of you know subtractive manufacturing. Just a brief example that milling is part of subtractive manufacturing processes, and it's subtractive because in that case you subtract, you remove material for creating the end part to create the final 3D object. So you have a starting material, which is kind of like a box. You remove you subtract the material, and then you create the 3D object. And then in the whole that process, you create some kind of waste, which is a bit bigger when you compare it with additive manufacturing. Why? That is because in additive manufacturing, the parts are created actually by adding material. Usually it's layer by layer. And when you add material, you create just a bit of waste only in the processes where some structures, like support structures, need to be removed at the end. So this is the base definition, what is additive manufacturing. Then if we go a bit to the characteristic of these two processes, I want to emphasize that additive manufacturing is not in the market anyhow to substitute subtractive manufacturing, because it has its own characteristics, its own advantages and disadvantages, unfortunately, as it is for subtractive manufacturing. So when you have subtractive manufacturing, the measurement accuracy can be way better. Also, as it is on the market, or it's used quite a lot through the years, it has a lot of materials, but also there are many applications that are developed for this kind of processes. Then when it comes to additive manufacturing, or 3D printing is more innovative technology, so it's around 30-35 years old. So there are many applications, and we see through the years that way more applications are being developed, as also is the case with materials. But one of the main characteristics with additive manufacturing is that you have a lot of freedom for designing, so a lot of freedom for shape, so complexity of parts. It's quite easy to use because you don't need to think as much for the design rules as in subtractive or formative manufacturing processes. So it's easier to use, and you can see later on, but it's kind of like just pressing the button and you would have a final part in most of the cases. Then it's way faster to produce parts with additive manufacturing. The lead times are usually way shorter, and it has ability to cut costs because it also has ability to reduce material in the parts. And about that, David later will show some examples of material and topology optimization. To go to the additive manufacturing technologies, I want to show this slide, which are the base categorization of additive manufacturing. So these are the 7 processes, and in these 7 processes, there are multiple technologies. We won't go through all of them now because it requires a lot of time. They are quite interesting, but also I want to emphasize only the ones now that we mostly use for machinery. So we first have extrusion. Extrusion is a process where you usually is used filament. It's extruded through a nozzle. And here we have fused deposition modeling and fused filament deposition. They are quite similar processes. Then VAT polymerization is also used in additive manufacturing for machinery sometimes. There are the technologies stereolithography, digital light processing, and continuous liquid interface production. I'll show you later on a video of how this works. This is just an introduction. Powder bed fusion are processes that are based on powder and here there are different technologies that are for plastic and for metals. We'll see the selective laser sintering process, multi-jet fusion, and selective laser melting. And then I'll skip material jetting because maybe it's not so interesting for machinery, but there is binder jetting, which is a process that can print metals, but also sand and ceramic. And direct energy deposition process, we won't go so much into it today, but yeah, it's good to know that you can print parts in metal with this process, and especially large dimension parts. So to go to extrusion. Extrusion, as I mentioned, it works by extruding filament. You might know it if you guys use it for prototyping, or if you use it as hobbies to printing parts at home, or just for, as I mentioned, prototyping. It is a process that usually uses plastics. So with filament, which is extruded through a nozzle, warmed up, and then deposited on a built platform, you create part layer by layer by adding material. There are also different materials. Like there are materials that are kind of a blend between metal and binder. And at the end, they could be sintered, and you have final metal part. Then there are different kinds of materials like clay, but also food can be printed with this kind of process. I want to show you here on the camera one part that is printed with FDM process.
Interesting.
Just a moment to switch cameras. Yes, there we go. If you select the screen with the camera, you can see maybe better the part. So this is a part just printed with PLA material. You can see that the quality of the part, it looks quite nice, but also you can see the layers of the material. What could be interesting for you is this PIC part. PIC is very often used in machinery, and it's quite strong, so it finds a lot of application in the industry. Then when it comes to FDM and FFF, there are materials that are composites. So composite is material that is contained by base material like ABS or nylon 6 or PLA, and then it has matrix in it like carbon fiber or fiberglass, and it makes the part stronger, or it enhances its properties. This part is printed with onyx. And here you have inside a nut that can be inside the nut that which thread can be used with the screw. Okay. I would like to change the slide, please. Okay, then we have wet polymerization processes. I mentioned them before. I would like to play the video here. Can we select the video for playing?
And that's video.
Okay, there we go. Oh.
All three.
Okay, I can explain it also without the video. Then people, please feel free to check the video afterwards. It's just how the process
works. All 3D printing technologies create solid parts from 3D model.
No, it's okay. I can explain it without the video. Then people can check the video themselves. We can go back to the presentation. So basically, stereolithography processes are processes that have a liquid resin as a base material. And in this case, UV light is used for solidifying the resin. There are 3 different processes here, stereolithography, digital light processing, and continuous liquid interface production. They are all kind of similar with small differences. Like, for example, in SLA, you have a pointer of UV light that solidifies the resin where it's necessary. Digital light processing, it works with projection. So at one time, whole layer is projected and solidified. Continuous liquid interface production is similar also with projection. It has here one trick though. There is this oxygen layer. You can see the blue line there on the icon. The oxygen layer helps the whole flow of the resin to go faster, so that improves the speed, but also in some cases the quality of the parts. We just want to show you here shortly the processes and the capabilities of these processes, maybe through the video, or if you have any questions, feel free to reach to us afterwards. Then I want to show you powder bed fusion. This is the process maybe used quite a lot in machinery. In our experience, I would say the most. And it's a process that can print both plastic and metals. In the two cases, you have a full bed of powder, and when it's plastic, the whole 3D volume of the bed of powder can be used to put parts inside. It's quite interesting because here support structure don't need to be used, while in the part below with metal, you see that there are support structures. Also in the previous processes that I just explained, there are support structures used. And when they are in the design, they a bit reduce the complexity of the part. So for plastics, powder bed fusion, it's very, it has a lot of advantages because these support structures are not necessary, and then the whole volume of the machine can be used to place parts. There can be also movable parts created. So for example, this box here, you see the hinge in this box is created in one go. So this is printed at one time, and no assembling time is necessary afterwards for making this part. I would leave it here in front of the camera so you can guys see it as soon as we change cameras. Yes, there we go. So here you can see that this is a movable part which is printed in one go. So again, no assembling time. Okay, this is similar, just different color. And then we have another one which is also with kind of a hinge. So this is a movable part, again, produced in one print. Okay, good to go. What I want to also to emphasize for these processes is that even though powder bed fusion for plastic, like selective laser sintering and multi-jet fusion, are very interesting and can create very complex parts, also kind of flexible parts. They are not approved yet for clean room applications, which I know you guys might use it quite often. But also the same is the case with VAT polymerization materials, but with the materials on FDM, there are some that are approved. And for metals, selective laser melting is also approved for clean room applications, so it can be used. Selective laser melting, again, it works in a base of powder, and there in selective laser melting, there is a laser source that melts the powder. And in electron beam melting, so the next process, it has electron beam as a light source that melts the powder. However, selective laser melting is the one that is used more because it's easier to use. However, here we have support structures because the power required for the laser to melt the powder in metal is higher, so it creates so-called a melt pool that it cannot sustain itself, so it needs an additional structure to hold it in place. I think there are some examples later that we can show you how it works and for what kind of examples it can be used. Yeah, then when it comes to materials, there are many. We have a big database of materials. I here just pick the ones that are maybe used most in the machinery industry. So for FDM or FFF, the extrusion processes, we have ABS, PETG, Onyx. Onyx, as I mentioned before, is a composite material with nylon 6 and carbon fiber, chopped carbon fiber. And then we have Onyx with continuous carbon fiber. And there is PIC. For VAT polymerization, there are materials like ABS, like PP, like urethane resin and standard resins. These are usually resins that are being created to imitate materials that are well known, like ABS or polypropylene. For powder bed fusion plastics, yeah, you can see also in the examples later, but PA12 is one of the most used ones. Then we have PA11, flexible TPU material, so for flexible parts. Yeah, I don't know how much you can see from the camera, but this I can squeeze. I'm not that strong, I can squeeze it. Aluminium filled PA12, then for powder bed fusion processes, materials like stainless steel and aluminium and titanium. Yeah, in our experience, stainless steel is used. I will leave this here while I talk in the background, if we can make that happen. Stainless steel, in our experience, is one of the most used metals for machinery application. Of course, there are also aluminium and titanium, but from our experience, stainless steel is on the top. Okay. The presentation, please. Yes. Then this was a very brief introduction about the technologies. I hope you guys have some experience with it. If you want to gain some experience, of course, we will show you the rest of the presentation of how yeah, we use it. Maybe it can inspire you for you to use it too. So this is the process that is usually used for developing parts for additive manufacturing. So of course, it starts with defining the function and the goal of the product. Then when we define the functions, we create the structure, and defining of the material either comes before the designing or redesigning the part or afterwards. So it can be both. We will focus on this part right now in this presentation and mostly on the designing and the redesigning for additive manufacturing. But later there are stages like orientation of the model, preparing for printing, printing and post-processing. After post-processing, it could happen that the part is done, but with 3D printing is also very simple. It happens very often that you go back to the design stage, because you can alternate between versions quite easily and quite fast. So this can go many times, but also it can finish in the post-processing stage. So for when it comes to designing and redesigning for additive manufacturing, we have several steps or stages for it. This is in our experience. So first one is copying of the structure. So if you have one, yeah, let's say this has been produced with subtractive manufacturing and it doesn't need any redesigning. So that means that you copy the same structure and you use it for 3D printing. Then the next stage would be optimization of the part. And that means that you are optimizing the geometry around the part. This hasn't been like this, but it has been optimized, so it is designed for 3D printing. So the material around it is optimized, and yeah, you come to the final geometry of it. Integration is when there are multiple functions or multiple parts integrating into one. And then the innovative stage comes when you either use all of it before or you create something that is totally new. So you integrate, you optimize, and you create a new structure that could be produced only with 3D printing. Yeah, so I will leave now the stage to David to show you some examples from all these different stages. But before we go to that, we have several questions for you. If you can go to the next slide. Yes. So if you can use again the Mentimeter app and answer this question for us. One is, do you have experience with additive manufacturing technologies, and how much? So here you have different stages, so we can see.
Oh, see who's winning.
Okay.
It's a nice balance.
It's a nice balance, isn't it? Yeah. Mm-hmm. Yeah. This is also quite similar to the previous questions we had. So some of them for prototyping and for hobby, but also there are people that use additive manufacturing for end-use parts.
And 6 use AM very often. Good.
Very nice.
Yeah.
Okay. And then the next question, we can go to the next question for you guys. That is, which additive manufacturing advantage do you think can influence your field of working? And there are different fields here, different benefits that additive manufacturing can create. So you have weight reduction, cost reduction, functional improvement, customization, integration of multiple parts, increased complexity of the parts, lead time reduction, and stock reduction. I think that you might be able to choose multiple answers here. So not only one, whatever you see a benefits in your field, you can select it.
I hear it's possible.
It's possible. What is winning here? Complexity.
Complexity is running, yeah. And functional improvement.
Lead time is reaching it slowly.
Yeah. Customization is not
so
winning.
Popular, no.
Stock reduction also. I guess no one from warehousing is in the meeting.
Okay. Nice. Yes, we can continue to the next question, which is, if you have additive manufacturing experience, which benefits do you recognize? This is an open question. And it's more for the benefits, that if you had used additive manufacturing. So in your field, maybe there are one type of advantages, but if you use it and you have experience already, how do you use it and what are the benefits for it? Okay. Exploration. Okay, there are a lot of answers here. I like this.
Yeah.
Prototyping.
A lot of prototyping too.
Cheap. If you design it in the right way, but you will get to understand that. Speed, lead time.
Early visualization.
If you don't know, you can also add a funny one. We'll try to find it.
Make sure you use caps lock so we can really see it.
Hello. Yeah, that's something. Volume check.
Funny one. There is a funny one.
There's a funny one.
Funny
On the
one.
left.
Funny one. Quick and quick.
Cost. Okay. I think here prototyping would win if there was a choice.
Yeah.
Okay. Yeah, we can go to the next one. And the next one is if you, again, from your experience, if you had used additive manufacturing, which are the disadvantages that you find in it? So what you don't like in it? Really a bit.
That is clear. Okay, let's move on to the next one.
And non-uniform strength.
Rough surface, clean ones.
Lead time that's very specific.
Yeah. I think the AM competence team is also here. Strength. Cost.
Learning curve, accuracy, recycling.
I can't use enough of it. Nice. Unknown tolerance.
I like that answer.
But still, it's a bit fascinating, of course, how what kind of designs you can make. But if you don't have the reliability in place and the right roughness, then things get difficult.
Still niche. Rough surface. Fumes. Procedure.
I see a lot of topics that we can dive into, but
Yes.
unfortunately, we cannot discuss all of them.
However, at the end, we have quiz, and the price of the quiz is that you guys visit us in Additive Centre in the Brainport Industry Campus. So when you come there, we can discuss all of this. Okay, we can go back to the presentation then.
This one.
There is still one more, sorry.
2 more. All right.
Yeah,
One more.
Let's continue.
What is your experience with topology optimization and generative design? So if you guys heard it or used it, there are different options for answers here.
That's
Good. I think I want to know more is winning here.
Curious crowd.
Curious crowd. And that's good because David is going to show you more.
Yeah.
You're building nice bridges. It's a good bridge to the presentation again.
So let's stop here because if there's something else is winning, I cannot do the bridge. Okay.
All right. We